Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, range sum of binary search tree. So basically we have a binary search tree here, where we have two integers, low and high, and want to return the sum of the values of all the nodes with a value in this range, low to high, okay? So of course the property of a BST is that the left side is always smaller than the root node, and then the right side is always bigger. So for example, if we look at this tree, the values between 7 and 15 are 7 itself, 10 and 15, and the sum is 32. So pretty straightforward. So for this, we can really use a very simple, straightforward solution. We can just go through all the nodes using DFS, and then we can just add if the value is in this range or not, inclusive range or not. Of course, we won't be using any property of BST, but from there we can iterate on it and use a property of a BST, okay? So how to do that? Well, we need to just do DFS, normal DFS on a tree, so we pass a node. And then we need to do DFS on the left side, and DFS, of course, on the right side. But we want to return the sum, right? So let's call that the result. Initially, it's equal to 0. So here we can use like a node processing first, the node itself, and then we process the left side, and then we process the right side. Okay, so to process the node itself, we just need to check if it's in the inclusive range, low and high. And so we just check if the node value is in between low and high inclusive. If it is, then we can just add it to our result. So we add the node value. And then we do the same thing for DFS. We add whatever the DFS on the left side gives us, and then we add whatever sum the DFS on the right side give. Actually, we can also simplify this and just say for the left side and right side result, and then just return it. Okay, you can just return it like, you can just do return res like this. And then we need to also handle our base case. So our base case, if we no longer have any nodes, so basically that can happen if we go left, for example, of this one, or go left of any leaf, or right of any leaf, then we will get none for the node, right? So in that case, we just want to return 0 so that it adds nothing to the sum, right? And then at the end here, we want to call our function, so we just return DFS called on the root, okay? So pretty straightforward solution here. Let's run it, make sure it's good. And looks good, let's submit. Okay, so that passes. Now let's actually use the property of a BST where the left side is smaller than the node and the right side is bigger. So we know here that we only need to process the left side here if the left side is if low is actually smaller than the node value, right? So let's say if the low value was, let's say maybe the low value was 6. Then in that case, we know we don't need to go to this left side. Even if there were, let's say, a subtree here, we don't need to go here because we won't find it because everything here is smaller than 5. And so there is no need, you won't find anything that is bigger than 6, right? So that's the key point here for the left side. So how do we do that? Well, we just need to check only if the node, the left side, only if the node value, so in this case 5, so we said if it's 6 and this is 5, so what is the comparison here? If the node value is, only if the node value is actually, here the left side is bigger. So if the left side is bigger, right? So if the low value, let's actually write it in comment first. So if the node value is smaller than low, then that means basically going left is useless, right? Because that means basically that the left side is, because the left side is smaller than node.left. So that means it's smaller than low. So you won't find anything that is bigger or equal to low. So what's the opposite case where we need to look left? Only if the node.val is actually bigger than low, because that means, for example, here, let's say the case or where it's low is actually 3. In that case, 3 is smaller than 5. We should look here because we may find something that is bigger or equal. So if it's bigger, then in that case we want to do the left side. So we do it like this. Now, what about the right side? So let's see for the right side in what case we need to process it or not. So if the node value, we need to process it as long as it's smaller than high, okay? But if the node value is bigger than high, so if the node value is bigger than high, we know that the right side is node.right is bigger than node.val, right? So by this equation here, we know that this means that node.right is bigger than high, right? So that means we won't find anything that is in this inclusive range. So if this is the case, we don't need to go right. So what's the reverse case where we need to go right in that case? Well, if it's smaller, so if the node value here is smaller than high, then that means basically, let's say, in this case, for example, 15 is bigger than node value, right? So that means potentially if we look right, we'll find something that is between 10 and 15. But if it's smaller, let's say if it was 9, then there is no need to look here because you won't find anything that is smaller than 9, okay? So that's the idea here. And so that's what we do. And that's pretty much it. That's the only change we need to do. But this basically will prevents us from going left or right when we don't need to. So if we run this and submit, it passes. Okay, so yeah, that's pretty much it for this problem. Pretty straightforward. The main thing to make sure of doing is if you have a problem with BST, to actually use the property of that sort of tree to optimize your solution. Yeah, so that's pretty much it. Thanks for watching and see you on the next one. Bye.